Welcome back, my dear students. Here we are studying the gear drives here. Till now we have studied that some terms used in case of the gear drive. So now we will study that gear trains. Trains means what? Train means the bogies are there, they are connecting one to other. Engine will be there at the front. That engine will take all the bogies that are connected to that. So where that actually power source, where it is available in the engine it is there, that engine will take all the bogies. So the power is not available in all the bogies that are connected to the engine will give that power to move to the other bogies here. Like that, gears are there. In case of the gears, for example, if it is a driver here now, if this is a driver, this is a follower. If we want to transmit the power from this gear to this follower, then how to transmit? It is not a belt drive here now. In between these two gears, number of gears has to be used. Number of gears has to be used, then they have to be engaged, then this driver will transmit that power to that follower here now. So therefore, number of idler gears, these are in between these two, driver and follower. First driver and last follower. In between these two, number of gears are used. They are called as the idler gears here now. They are called as the idler gears here now. So then it is called as the gear train. It is called as the gear train to transmit the power. It is used here now. That gear train is used. These gear trains there are two types of the gear trains. One is a simple gear train. Another one is the compound gear train here. Simple gear train means what? For example, if I take this is the driver here, if this is the driver that gear here, the next one is the another one, if this is the follower. Yes, this is the follower that gear here now at the end. So if this is the driver, if this is the follower, we want to transmit the power from this driver to the follower here, I have to take another one gear like this here. So this is another one gear has to be taken here like this here. Then this gear is called as the idler gear. Then this is called as the simple gear train here in this case. So what is this? How this directions of this gear? So if this is the driver is moving in a clockwise, this idler will move in a anti-clockwise. Now in this case, if I take this is the first gear here now, this is the second gear here now, this is the third gear here in this case. If I take first and second, now this first is a driver and second is the follower here now. Next one, this is anti-clockwise, then it will becomes the clockwise here. So now the idler gear will becomes the driver and this follower will become the last follower here now. So in these cases, what we can analyze here now, if, see this one now, driver is moving in clockwise and follower is also moving in a clockwise here now. Both are moving, first driver and last follower, both are moving in a same direction. See here now, clockwise, here also clockwise here now. What we can analyze here now, if the idler gears are there, they are in odd numbers, like 1, here is a 1 here now, 1, 3, 5, 7. In between the driver and follower, idler gears are in an odd number, 1, 3, 5, 7. Then driver and follower are rotating in the same direction. This is a rule. Definitely it will comes like that here now. If the idler gears are there, they are in the even numbers, like 2, 4, 6, 8, like that, in between the driver and follower, then definitely the driver and the follower will rotate in the opposite direction. Means if the driver in clockwise, the follower will be in anti-clockwise. Then that idler gears are in even numbers here. That is a rule, it is there here. So now what I will do, I will go with the velocity ratio here. Velocity ratio for this. So how to give this velocity ratio for this one now? I will take this usual notations for this. For first gear, D1 is the pitch circle diameter. I will take it as the Z1 is the number of teeth of the first gear, and N1 is the speed here now. Similarly for the second gear Z2 and N2. Third gear here now Z3 and N3 here in this case. Next what I will do here, now I will apply the velocity ratio for the first and this second gear here now. So this is the driver and now this is the follower here now. How to write this velocity ratio here? N1 divided by N2 is equal to, it is Z2 divided by Z1 here now. This is equation number 1 here now. So next I will apply the next velocity ratio for the second and third gear here now. Second and third gear, N2 divided by N3 is equal to Z3 divided by, it is Z2 here. So this is equation number 2 here now. What I will do, I will multiply equation number 1 and 2. So therefore equation number 1 into equation number 2 I will multiply here now. So therefore it is N1 divided by N2 into N2 divided by N3 is equal to Z2 divided by Z1 into Z3 divided by Z2 here. So see this in this equation, this N2 will get cancelled, Z2 will get cancelled. So at the end what we are getting here now? At the end what we are getting here now, see here. So N1 divided by N3 is equal to, it is Z3 divided by Z1, what we are getting here. So this is I. This is for the gear train, this is the velocity ratio I here now. What it is indicating here now? It is indicating the velocity ratio, it doesn't depend on the number of teeth and speed of the idler. See here now, here N2 is not appearing and Z2 is also not appearing in the final equation here now. So therefore, definitely in case of the simple gear train, the velocity ratio will depends on the number of teeth on the driver and follower as well as speed of the driver and follower. It doesn't depend on the speed or teeth of the idler gears here now. So this is velocity ratio here now. So another one the velocity ratio is also another one way of writing this one. Velocity ratio is the reciprocal of train value. So or else train value means what? It is the reciprocal of velocity ratio. That is another way of writing. Usually in case of the gear trains and all, we are writing train value here. So it is the reciprocal of velocity ratio here, nothing but here. So next one we will go to the compound gear train here. So that is another gear train. It is the compound, that is gear train here. How this is? What is this compound gear train means what? How this one now see here? This is the one gear. It is a driver here now, and the next one, the compound gear means there are two gears are fixed on the same shaft. Both are the idler gear. Both are the idler gear here now. How this one now? See here. This will engaging with one gear. Yes. This is engaging with one gear here now. This is the idler gear. The follower is somewhere here now. So therefore, next one is, so another one gear is there. It is fixed on the same shaft here now. So this is the shaft here. This is shaft here now, right? Idler gear. These are the idler gear here now. On the same shaft, two gears are fixed. This is gear 1, gear 2 is engaged. 1 and 2 are engaged here now. And third gear is there. It is fixed on the same shaft here now. Same shaft here now. Then the last follower is there. It is fixed with the third gear. Like this. Here, fourth gear. It is the last follower here now. So what happens like this? If I am taking like this here, the idler gears are two because they are fixed on the same shaft here now. That's why they are rotating with the same speed. That is here in this case. So therefore, here in these cases, how that velocity ratio will becomes here now. First I will write 1 and 2 here now, because 1 and 2 are engaged here. In this case, N1 divided by N2 is equal to, it is a Z2 divided by Z1. Call this is equation number 1 here. The next one is, the third and fourth are engaged here now. It is N3 divided by N4 is equal to, it is Z4 divided by Z3 here now. All this is equation number 2 here. So now, what this one now? So I will multiply, same. If I multiply here, it is N1 divided by N2 into N3 divided by N4 is equal to Z2 divided by Z1 into the Z4 divided by Z3 here. But the second and third gear, they are fixed on the same shaft here now. So therefore the N2 is equal to N3 here now. So N2 is equal to N3 means these two will get cancelled because they are fixed on the same shaft here now. Next, how this relation is modified here, sir, here now, see here. So it will becomes N1 divided by N4 is equal to, it is the product of Z2 into Z4 here divided by Z1 into Z3 here. This is the relation what we are getting. What this relation is telling here now? The speed is there, N1 divided by N4. This is a velocity ratio. N1 is what? It is the speed of the driver. N4 is what? Speed of the last follower here. So it is a velocity ratio. This is equal to what it is there? The above here now, Z2 into Z4. Z2 is the follower of the first gear. Z4 is the follower of the third gear here now. That means what? This is what here now? This is the product of number of teeth on the followers here now. What we are getting here now? Here this is the product of number of teeth on the followers. Z2 is the follower of 1 and 2 is the follower of 1, 4 is the follower of 3. So therefore it is the product of number of teeth on the follower. And coming to this denominator here now, denominator what it is telling you now, Z2 into Z3. Z1 is what here now? It is a driver. And Z3 means what? 3 is what here now? It is also driver. That means the denominator is the product of number of teeth on the drivers here. So therefore, in case of the compound gears, velocity ratio is the ratio of speed of the first driver to the speed of the last follower. This is one, N1 by N4. And also, it is the ratio of the product of number of teeth on the follower to the product of number of teeth on the driver here now. That is the equation what we are getting in case of the compound drive here now. If you want to train value, if I want to write a train value, that is a TV, it is 1 by I here, as I have told here in this case. This is about the compound that gear drive here now. In this chapter, whether it is a belt drive or a gear drive here now, very simple numericals will be asked, especially in gear drive also. Very simple numericals, which gear is engaging which one, the engagement of the gears are given. So sometimes in the numericals it is given like this, 2, 3. 2, 3 means what? 2 and 3 gears are engaged here now, like that. So very simple numericals we can solve in case of the gear trains also, as well as in case of the belt drive based on the equations here now. So this is about the belt drive and gear drive. Please go through that all my video lectures very sequentially and also refer that snaps of the textbook and try to solve the numericals, because these are very simple numericals that are available in the textbook snaps. Be safe, stay in home and keep learning. Thank you very much.